Hi, everybody. Happy Thursday. Hope you're doing well. We are moving on to our next subject today, but our warm-up today is going to be reviewing the dilations that we talked about earlier this week. So go ahead and find the scale factor. Make sure you're paying attention to which of these is the pre-image and which one is the image. Okay, so some of what we're going to do today is review from first trimester on transformations. We are just adding that to similarity. So we have to decide if something is similar, and then we have to walk ourselves through the transformations that were used. Okay, so to determine if figures are similar, what you need to be looking at is that the transformation image at the very end is the exact shape as its pre-image, okay? It can be a reflection, it can be a translation, it can be a rotation, it can be dilated, but the shape cannot change. So you can't start with a triangle that looks one way and have a different looking triangle at the end. It can't go from a square to a triangle. It has to look exactly the same. And we're going to go through some examples of what that will look like. So just a transformations refresher, because it has been since probably October since we talked about this. So remember, a translation is moving the figure right or left, depending on the X, or up or down, depending on the Y. Okay, a reflection, we have rules for this, but it's reflecting over the X-axis, over the Y-axis. Rotation, we're rotating around, and dilation makes the figure bigger or smaller. Okay, if you do not still have these, I did put these back into the slideshow for you. So these are our reflection rules. Remember, you start with this point. This is what happens if you reflect over the X-axis. This is what happens for the Y equals X, Y equals negative X. So if you cannot find this, I would recommend either taking a picture of it or writing these rules down. Same thing for rotations, okay? Rotations is moving around, right? And you need to make sure you pay attention to clockwise versus counterclockwise, okay? And again, your pre-image and your image will change based on that. So if you do not have this or cannot find it, write it down, take a picture. Okay, and so we're just gonna kind of go through and start recognizing, okay? So the first thing we need to do is recognize whether the shape of this figure is the same. That is the first thing we do. If it's not the same, then we stop there. If it is the same, then we start looking at, okay, what kind of transformation happened to get this triangle from one to the other? Okay, so for this one, first of all, are the figures similar? Hopefully you would say yes. They both look exactly the same. They're just in a different location. So up here in this quadrant 1, EFHG is our pre-image, and this down here in quadrant 3 is our image. So how would we get here? Well, notice that EF is now down here. So we did not translate. We did not go down and over because the figure moved. We did not reflect. We did not dilate. So the only thing that we can say we did was rotate. Okay. And one of the easiest ways to decide what we're doing on this is to, wrong direction, is to choose a point and see kind of what happens. Okay. But again, just let me visualize this. Translations move up and down or right or left, and we know that that didn't happen. Okay, reflections go over the top, and so they look like you could fold a piece of paper in half and match them up. So we know that didn't happen. It didn't get bigger, so that's why we're focusing on rotation. So I'm going to pick this point right here. This point is 4, 1. Okay, and I am going to recognize that this same point right here is -4, -1. Okay, so if I go back here to rotations, I need one that changes my X and Y to a negative X and a negative Y. And the one that makes that happen is a rotation of 180 degrees, which tells me that this figure rotated 180 degrees, and you could say clockwise or counterclockwise because 180 is obviously half of a circle and it's going to be the same no matter what. Okay, so this was a rotation. And hopefully as we go through some of these, it's going to be a good refresher and you're going to remember this from the fall. All right, so now we're looking at this. Are the two figures similar? So take a second, look and see what you think. Okay, this is an example of one that you're going to have to really, really pay attention to. So the actual answer to this is that they are not similar. They are actually different sizes. And I can pull this up and kind of show you what I mean by that. Okay, this original one is a 2x4, okay, rectangle. This new one is a 4x7 rectangle, and there is no way for us to take a rectangle that's a 2x4 and make it a 4x7. This would have to be an 8 in order for it to be similar, and it's not, which means that the figures change size, and so therefore they are not similar. Okay, so I don't want you to automatically assume when you see two rectangles that that's what they are. You need to do a little bit more investigation. So because these are not similar, we don't even talk about a transformation because it's not possible because they're not similar figures. All right, what about these two? Are these two figures similar? Hopefully you would say yes. Okay, hopefully you would say yes. And again, I am going to pull up this other one. So, okay, so hopefully you would notice that these two figures are the same. Okay, so then we start going through our list of, okay, how did we get somewhere? So did we move up or down or right or left? That would be a transformation, and we did not. Okay, did we rotate something? And we would say no. This is actually a reflection. Okay, if you were to fold this right here in half and fold it, they would match up. So this is a reflection. And then you have to decide, is it a reflection over what? Well, it goes right down the y-axis. So you would say that this is a reflection over the y-axis. Okay? And that's all you would have to do. Okay? What about these two? Are these two figures similar? Okay, so again, you would have to do a little bit of investigation just because you want to make sure that their dimensions are the same. So what I would recommend doing is just counting that this is 1, 2, 3, 4, 5, 6, and it is 1, 2, 3 tall. This one is now 1, 2, 3, 4, 5, 6 tall. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a 3 to 6 became a 6 to 12, which tells us, yes, they are the same. And because of that, we know automatically that this is a dilation. Right? That's what it did. It got bigger. And so that's the change that this made. Okay? So hopefully you're getting a little bit better about being able to recognize similarity. Okay, what do you think about this one? Do you think these figures are similar? Okay, hopefully right off the bat you would notice, no, they are not. These triangles look totally different. So yeah, they're both triangles, but they both look totally different, which means they cannot be similar. There is no transformation. So you would just say not similar and you would move on. Okay. What about these two? Well, we're going to go back and do what we did, which is see what our relationship is between them. Okay. So what our relationship is between them, let me pull up this other one for me again. So this is a 1, 2, 3 by 1, 2, 3, 4. Now it is a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. Okay. So yes, they are similar. We know for sure that there was a dilation that happened here, right? And we notice that it moved. Notice that it moved up and over to get there. So there's also a translation that happened. Okay. We don't know enough information to know which one came first, whether it translated and then dilated, or if it dilated and then translated. Doesn't matter. We just know that we got bigger and we also moved up and over. Okay. So that means that our translation would say X plus something, Y plus something. And in this case, we know X would be 1 and Y would be up 2. So that would be the official transformations that happen to this one. A dilation, right? And we could even get more specific and say the dilation happened at times 2. And we translated over 1 and up 2. Okay? Alrighty. Okay, so now we're going to start talking about sequences of transformations, kind of like that last one we just did, right? That last one we just did, we did find that there was more than one thing that happened. So we're going to start talking through that on this as well. Okay, so look at it really quickly, see if you can determine what was done, and then we are going to decide this. So we're going from ABCD or ABDC to DEFHG. So this is our pre-image. This is our image. What are we doing? Okay, so hopefully you are able to see that this figure obviously moved down and over, right? And obviously it got smaller, okay? It also got smaller. Okay, so if we know just those two things, we should be able to figure this out. Okay, so I am going to say that we moved it first. So that means that we translated. And we translated by taking our original figure and we went over 1, 2, 3, right? From here, from C to G, right, would be there. So we went over 1, 2, 3. And in Y, we went down from here to here, right? We went down 1, 2, 3, 4. So that got us from here to this same location. And now we have to figure out, well, what did we dilate by to be able to do this? And we know that it has to be a fraction because we went smaller. So we know that we went from 1, 2, 3, 4 across to 2 across, which tells us that we cut it in half. So this would be our sequence from translation to dilation to get from our original figure to our smaller, newer figure. Okay? Let's look at another one. Okay? We are going from this smaller one to this bigger one. So go ahead and look at it. See if you can figure it out. All right, so I am going to pull up this other one. So obviously we went from a smaller triangle to a bigger triangle. So there has to be a dilation. Okay. And obviously It didn't move, so there's no translation. It didn't reflect, so the other motion has to be a rotation because the figure was rotated. It did move. So the easiest way to figure out your dilation is to go from 3 to 9, which tells us that it is 3 times bigger. Okay. And then because it tells us that J and P are the same point, okay, J and P are the same point, J is actually the point 0.01. And if I dilate it, it's the 0.03. And now P is the 0.30. So I have to look back at whichever rotation goes from an XY to a YX. And if I go back and I look at my rotations, I notice that the only ones, and there's 2, which are the same thing, they go from an XY to a YX. And notice it says -X, but -0 is still 0. Is 90 degree clockwise or 270 degrees counterclockwise. So you could say that it's either of those, and both of those would be correct. So you would say 90 degrees clockwise or 270 degrees counterclockwise. And that is the transformation that takes our small triangle to our big triangle. Okay. Let's look at another one. Okay. Again, the very first thing that you should notice on this one is that we're going from a bigger figure from a bigger figure to a smaller figure. So you know there has to be a dilation, and it has to be a dilation that is a fraction. And then we're moving and reflecting. There's actually 3 things that we're doing in this one. Okay. So let me pull this up. Let's do the simplest one first, which is the dilation. We are going from 1, 2, 3 to 1, which means we're dividing by 3, which means our dilation is K equals 1/3. Okay. Now we're actually going to move it. Okay. So we're going to actually, let's reflect it first. Let's reflect it first. We are going to reflect over the y-axis, because notice that we went from this way, where it's pointing this way, to pointing this way, which means we folded it in half. And then that would get us over here to 1, 2, 3. So 1, 2, 3. And now we're moving from here to here. So we are translating X. Let's see, we are translating X plus 1, 2 and Y minus 1, 2 to get to our new figure. Okay. And we're going to do a lot more practice on this. Okay. So I don't want you panicking because you're still not figuring this out. Just start recognizing things, and hopefully it will start getting easier for you. Okay. And then lastly, we're going to talk about this one just really quickly. Okay. This one is obviously going to be a dilation a little bit. It's moving and it is reflecting. Okay. So, or rotating, I mean. So you know it's rotating because this figure is now down here, right? C and F relate. So it had to have rotated. Okay. And we know it moved because instead of it being at the same place, it's at a different place. So we're not going to talk specifically, but this is what I want you to start seeing, is that you can start recognizing that something was done to get you from here to here. C became up here, so we rotated around. We got bigger, okay, things like that. So today's exit ticket is just 2 questions. 1 to recognize if something's similar, and 1 to recognize what kind of transformations are happening. You don't have to say what exactly they are. You just need to know, is it translated, dilated, reflected, or rotated? Okay. Have a fantastic day, and please let me know if you need any help with anything.